So in this talk, I will give you 8 practical tips from implementation of our app, because we started implementing with the new Firebase from February this year. We have been working with Google even before it was announced on I/O, so we have some head start, and I think you will find this useful. So first, about our app, what is it about? So the app is called Settle App. You can already download it in Play Store, App Store, Windows Store. And this is our new redesign. We have redesigned it from scratch. We are using the colors for every group has a different color. And we are building this on Firebase. The app is for sharing expenses. What's sharing expenses? That's when you go with some friends to a trip, or maybe you have flatmates or for couples, you have some shared expenses. Somebody pays for accommodation, somebody pays for gas, stuff like that, and you input all these expenses into the app, and the app tells you who should pay next and who owes who. So it simplifies, it solves this problem. Okay, and now Firebase. So you have probably heard a lot about Firebase. Google is promoting Firebase on every event. Yesterday there was a really nice Firebase workshop here. And as you know, Firebase is a set of multiple tools which help developers to create apps more easily. It's cross-platform, so it's for Android, iOS, and web. And I just want to tell you how we are using different features of Firebase in our app. So right now we have backend in App Engine, all the data is in App Engine, but we are migrating all the data to real-time database. It's great because it solves synchronization for us and also offline. So many code can be removed because we don't have to deal about synchronization and offline. We are using authentication for Google sign-in, Facebook sign-in, and also email and password sign-in. It also removed so much code about authentication. Cloud messaging, that's just normal for push messages. Storage, we use it for saving receipts, user-generated images. We use Firebase hosting for our web app, so we also have like progressive web app, which is hosted on Firebase hosting. Remote config, we plan to use it for A/B testing and also feature flags. That's a really powerful feature that we can ship and update like before we turn on the feature. So we ship update like 2 weeks before. Then we turn on the feature for maybe 2% of users. We test that everything works well. If it works well, we increase the percentage. If it doesn't, we put it back to 0%, fix it. We use Test Lab for a robo test before every release to the Play Store. And also we have some espresso tests, which we use during the development. We use crash reporting as a replacement to Crashlytics. Before we use Crashlytics, now crash reporting, mostly because everything is nicely in one console together with analytics, so that's really nice. So we use analytics, that's like only compulsory feature of Firebase. Like if you include any of this, analytics is also there. And from the other, we use dynamic links. So dynamic links are these links which deep link into your app, and it survives app installation. So we use this for invitation to groups. Inside our app, there are like group of friends, and you can share this link using anything like Facebook Messenger, email, whatever. And when the invitee clicks this link, he goes directly into the app, so he can skip the onboarding and everything. Like we already know that this user wants to join this group. It really helps the onboarding. Okay. So now let's move on to the tips. So first, I would start with MVP. We are using model view presenter architecture, and we have been discussing and solving where to keep the listeners to the Firebase. Because when the app is connected to the Firebase, then it keeps the permanent socket connection to Firebase servers. So you should not keep this connection all the time, only when the user is inside your app, because it drains battery if you keep this connection all the time, even on the background. So we decided to use MVP, and we have listeners to Firebase in the presenter. But also then there is a problem about the rotation, because we don't want to recreate the presenter every time the device rotates or there is some other configuration change. And we don't want to unsubscribe and subscribe to Firebase. So how can a presenter survive a configuration change? The answer is loaders. Loaders is really great component for solving exactly this problem. It's in Android framework. So it survives rotation, but it also goes away when the fragment or activity goes away. So that's ideal for a use case. So here's some simplified code from our app. I hope you can see it. It's quite small. No? So I will explain. So this is a base fragment, and we keep the reference to the presenter in this base fragment. It's created there, and there is two methods, attach view and detach view, which is called on the presenter when it's attached or detached to the view. So in the presenter, we keep the current state of the data. We set it in the attach view and detach view. That's after rotation, but it's not reloaded. It's cached in the presenter. And this is the loader which loads it. It's quite simple. It's a synchronous loader, and it calls methods onCreated by loader and onDestroyed by loader in the presenter. And in these methods, in onCreated by loader, you subscribe to Firebase, and in onDestroyed by loader, you unsubscribe to the Firebase. There are links at the bottom of my presentation here with a source material. There is a nice article about this explaining in detail this problem, and like all the code you can get from these links. Okay, let's move on to RxJava. So RxJava is really great match with Firebase real-time database, because all API for Firebase real-time database is asynchronous. You always get asynchronous callback, and you should also flatten your data. That means that you will be calling to multiple endpoints in Firebase to assemble one screen, for example. So RxJava is really helpful that it can coordinate many asynchronous calls. It can easily handle error handling if something goes wrong. So Rx is really great match with Firebase. But like the official SDK doesn't have reactive extensions. Like it doesn't give you observables. But it's quite easily to wrap it like this. So we have a database query, and we are using this API from RxJava called fromAsync, observable.fromAsync. It's a new API since like 2 months ago, I think, in Rx. And it just wraps these callbacks and creates observables. It's quite easy. And nice thing about fromAsync is that it also handles back pressure and other stuff for you. Another tip, So when you subscribe to Firebase events on a list, you get callbacks like something has been added, something has been edited, deleted, or moved. This is really nice, like a list of items when you have. So you can plug it into Recycler view, and you have these nice animations. But there is one API missing. Like you don't have a callback when the list is loaded. Because usually in the UI, like first you want to display some progress bar that is loading, then it's loaded, and you show the content, and then you keep listening on the changes that something has been added or deleted. So how to do this? It's quite easy, actually. You can use Firebase API called AddListener for single value, because we just need it once. Like in the beginning, when it's loading, we just need it once, so we don't need to keep this listener. And we also wrap it in RxJava, and we generate an event on the observable that it's loaded. And we also use the observable from async, same API as before, to wrap it. Now let's dive deeper into real-time database. So the question I get most from other developers is how to structure real-time database data. I think this is one of the hardest parts when you decide to switch to Firebase real-time database, because you have to be really careful about structuring your database. Querying in real-time database is quite limited. That means that you can only sort stuff and then limit stuff. Like you can sort by score, for example, and then take first 5 or last 5. There is no like where queries you are used to from SQL. So you have to really carefully design your database structure in this NoSQL database. So I will give you. We have been iterating a lot. And if you are also considering switching to Firebase real-time database and you are not sure about the structure, feel free to contact me, send me your structure. I can give you some tips. But first, I will give you some examples from our database. Can you see it? Good. So we have transactions here and groups. So that's our main like tables in our app, transactions and groups. And you might have an idea. It's a JSON, so you can nest things. So somebody could say, hey, let's put the transactions and nest it into groups, like groups/group ID and transactions. The problem with this approach is then in the UI, when you want to list like a list of groups and maybe just the group names, the group name here, if you just want to list the group names, you would also need to download all the transactions for each groups, and like you don't need it at that time. So it's a bad practice, and that's why you should flatten the data. And flattening means putting it on the root, like to different node, which is kind of like a table, and put the group ID there. So you can do different requests just for the transactions. So when you are downloading groups, you don't need the transactions. If you need the transactions, you will do different requests to Firebase. So that's basic. And then something more complicated, which is M2M relationships. If you have M2M relationships in your database, for example, this is our M2M relationship. We have users and permissions, like user groups and permissions. User groups is like groups of a user, and permissions is permissions inside one group. And as you can see, like you can reconstruct user groups from permissions and vice versa. It's kind of duplicated data. And in this case, it's completely OK For M2M relationships, you have to duplicate the data, otherwise it will be too costly to query it. But also if it changes, you have to change it on 2 places. And something more from the database structure. So how about arrays? Firebase real-time database it looks like a big JSON. It's actually not like some JSON stored on Google servers. It's a NoSQL database. But for you as developer, it looks like a JSON, and it supports all the features of JSON. So one of the features of JSON is arrays. So is it OK to use arrays in Firebase? Well, in documentation, it's really discouraged. They try to persuade you to avoid them, but we use them. And I would like to explain why we use them. So first, why not to use them? The arrays are complicated because of concurrent access to the same data. If you are updating the array, like 2 users are editing the same array at the same time, some conflicts can happen, and Firebase can't solve them automatically. So this is a problem. Firebase is designed that it solves all the synchronization for you, and there is nothing like say which version is better or something. And it could happen that the indexes in the array can mismatch, and it can break your app. So if you have an array and 2 concurrent users can edit it in the same time, never do this in Firebase. But we use it like this, and what's the advantage of arrays? It's actually simplifying a code a lot. Because when you get the object from the JSON to Java, the arrays creates lists in Java, and it's really easy to work with them. And also create new records, it's just one call to Firebase. If you don't have arrays, you would have to create many calls to Firebase for every item. With the push method. So we have arrays like this, transaction can have different items. It's an array. But the trick here is that in our app, we always update the whole transaction object, whole thing. We update it at once. We never update just the items or just some part of the array. We always in the UI, we keep the object just in Java. User can play with it, edit it, and at the end there is save button. He clicks save button, and it goes to the Firebase. So it can never happen that 2 users are editing just the array at once. They will be editing the same transaction, and it will be overwritten like the whole object. So no conflicts can happen there. Okay, another problem we have been dealing with is how to sort items in a list coming from Firebase in descending order. Because by default, it's in ascending order. Here's an API how you can sort stuff in Firebase. So you can order by key. That's a default ordering. If you don't specify ordering, it's ordered by key, and the key is also based on time. So it's ordered that the newest thing is at the bottom. But we wanted the newest thing at the top, not at the bottom. So you have some different options, like order by child in your Firebase or by value. And so we thought that we have to create something like a negative timestamp. We create negative server timestamp, we put it into Firebase as a child, and then we order by this child. So how to create this negative timestamp? There is a hidden field in Firebase called info.serverTimesOffset. And you get offset from your local time to Firebase servers. And you can create this server times offset even offline. Like you don't need to be online for getting this server time. And I talked with some Googlers about this approach because we were in this early access. And they told me it's kind of hacky, and they don't recommend it. And what they recommended me is just download it normally and then flip it on the client. So that's what we are doing now. We just flip it in the adapter on the view. Okay. So last two tips. So now about monetization a little bit. How does pricing of Firebase affect monetization of our app? Here is a screenshot from the monetization. And currently, we have monetization mostly based on new users. So new users pay for our bills. And you can all read this at home, but the most important number here is 2.5 gigabytes in real-time database, gigabytes stored. It's gigabytes stored in real-time database, but it's important that this number is not per month, like stored per month, but overall. So this number will always increase, and there is a risk when you have money only from new users. When something happens and new users decrease, but you also have the existing users which you have to pay for, that you can start losing money or get into trouble. So I think when you are using real-time database, you also have to monetize existing users, so you get also money from existing users. And how we solved it, we are switching the monetization to kind of like a storage model. So people will have some free storage of transactions in our app, which directly mirrors to transactions in Firebase. And if they go over this limit, they have to pay some money or view some ad, or there are multiple ways how they can increase this limit. And it directly mirrors to the pricing of Firebase. And users also have an option to archive the groups, because real-time database should be really used just for the real-time data. It should not be used for some old data, maybe some groups of transactions from a year ago, which are there just for history. So we have option to archive it, and we will just take the JSON from the real-time database, we download it, and we put it into cheaper storage, which is file storage, which is much cheaper. And it's not real time, but it's sitting there. And user can, every time he can take it back from the cheaper storage to real-time database and then interact with it into the app. And finally, what about Windows? So we also have a Windows app right now, and Firebase is all about Android, iOS, and web. So what about Windows? Well, we haven't found any good library for Windows and .NET, so we wrote it ourselves, and it's open sourced. So if you plan to use Firebase database or Firebase authentication, that's the main building stones. In .NET, you can use our library, and we will be grateful for some contributions as well. So that's all tips. Thank you, and I will take some questions now.
Okay.
First of all, thank you for great talk. You mentioned the archiving of JSON to the cheaper storage and getting back to the real-time database. Do you not force users, but just informing them that if they get information from archive to real-time database, it will cost more or not? or it's just automatically? You mentioned that if a user is using a real-time database too much or something else, you are showing ads or asking for a pay. What about in this case? I think if archive is rather big, importing into the real-time database is expensive.
So the question is if we are notifying users that they are using the real-time database too much. So of course we don't tell users anything about real-time database or storage, that's technical terms. But we just say that it's a transactions they have into the app, that's the real-time database, and they can also put it into archive. And we have this limit which is visible into the app, they can see it, and they can work with it how they want. They can decrease the limit, increase the limit.
Okay, next question.
Hi, thanks for presentation. So we have like two questions. First, how you work with back pressure on like Firebase events, and second one, how you work with first loading. So I understand you're using like observer once, but what you do exactly after it? So you get first data from callback and then start observing for children and filtering on client side if it already exists on the list or not. Or how you?
First, let's do the first question. It was about crash reporting.
No, back pressure.
Sorry, I don't understand.
Back pressure. How you handle risks?
Back pressure.
Yeah.
Back pressure. Yeah, okay. So back pressure is handled by the from async call. You put the back pressure strategy there, and we use the back pressure buffer. So that means it will create a buffer of events, and it will be processed eventually.
Okay, and second one? Okay, sorry. About first loading of list. So we load full list from like a single event, and then you start observing by child?
You mean when the list is loaded?
Yes, yeah. Like we don't have callback for first loading list. Like these 10 items is like full first loading. So
okay, so the question is if we have the single listener and then the normal listener. Yeah. We actually listen to both at the same time, and it's guaranteed that you first get the loaded event and then something has been added.
Okay.
So we launch the same listeners at the same time, but the single listener is just one time. It just generates one event, it's loaded, and then it doesn't listen for anything.
Is there any like best practice how to do it? Like in this case, we will duplicate data, so we will get all lists twice, and if it's a big list, and so it's not so good.
You will not get data twice. You will get it just once.
Okay.
In the edit callback, it will be called just once.
And maybe last one. So, what about pagination? Do you work with the Firebase, like start and end using indexes? How you work with pagination?
Sorry, can you repeat?
How you work with pagination?
Pagination.
Yeah.
We don't have pagination right now. It's a mobile app, so you just scroll.
Okay.
Yeah. But it will be easily done with the limit, like you can limit in Firebase.
Okay, I see a question.
Hello, David. Thank you for presentation. My name is Tom. So my question is more about testing. You've mentioned that you have espresso tests, and this is a known practice to isolate your UI tests from backend stuff. In your case, it's Firebase. So can you advise some practices, if you use one, how you isolate your UI tests from flakiness that can come with server requests?
Okay, so the question is how we can isolate UI tests from the flakiness of server tests. We are okay with the UI tests being dependent on the network, but we also have different tests for like unit tests just for testing the logic, which are not dependent on the server. We are actually using a framework called Cucumber It's a really nice framework for creating cross-platform unit tests. So we have one unit test for all the platforms, and then you just need to implement this like little bridge on each platform, how the test translates, and it works really well for us.
Okay, so you are not isolating your UI tests from Firebase stuff. Yes, so your UI test basically runs through UI flow and make network requests, and then you assert UI somehow.
Yeah, we are not touching UI. We are just, this is unit test, so we are just calling our methods there and like testing our logic and mocking some stuff.
Yeah, but you mentioned espresso tests, and they are actually go through your UI.
Yeah, espresso tests are just clicking on the UI, and like we don't have many of them. Like we try to focus as much as code coverage with the unit tests, and the espresso tests are testing just the most basic feature before release, so it just clicks to the app. So we don't like to cover everything with unit tests, because if we refactor the app, then we would have to change the unit tests a lot, because we change the UI quite frequently. So we have just a little bit of unit tests, the UI tests, sorry.
Okay, thank you.
Okay, next question.
Hello, it was a nice speech. I wanted to ask how do you synchronize two calls to Firebase?
Sorry, how we synchronize what?
Two calls. You're making two listeners on two branches. How do you synchronize them?
Like where are you getting data or writing data?
Getting.
Well, it's usually like sequential. Like first we get this data, then if we get this data, we get another data, and then we connect everything in RxJava. So at the end of the Rx flow, there is one object with all the data we need. But if anything fails in this, there is one common error handling.
Thanks.